Hello everyone, this is Accent and welcome to today's video. Today's topic is about the difference between a linear search and a binary search in Python. Well, both of them have the word search, so you will be definitely searching for something. Well, where exactly? In the sequence, of course, like a list, a tuple, or a string. But for my example, I will go for a list. Definitely, we are searching for an element that can be from any data type in a sequence. Let us say I created a list from 1 to 100 and I want to check if 67 is in my list. Definitely, we'll be using loops. Let's say I start with a linear search. First, I'll do it with a while loop. Inside the parentheses, I need to mention parameters. Let's say the list and the number or the element I want to search in my list. Then let me declare my list, so I'll say search. Right now, I need to mention the list. My list will be a list that contains the numbers from 1 to 100. So this is a range of numbers from 1 to 100. Then I'm gonna mention the number that I want to check if it is in my list, so 67. Right now, let's write our code. We definitely know that with a while loop, we need to use a counter. So I'll say counter equal to 0. Right now, let's specify the while loop and the condition. I'll say counter less than len lst because we don't want to go out of range. Next, I will mention an if statement. So I'll say if lst index counter, I'll explain that later, equal to n. What I'll do is I'll print found at index, so I'll mention the index of it, and I'll say counter. So counter. But if lst index counter isn't equal to n, I'll say else. I'll just increment my counter by 1. Counter plus equal to 1. And then I will mention an else statement that belongs to the while loop. So if the while loop evaluated false, that means if the loop terminates, the block of code that comes inside this else statement will be printed. So I'll print not found. So what did I said here, lst index counter? So lst index counter, first counter is at 0. lst index 0 equal to n, while n is 67. Here we have 1, definitely not. Well, we'll go to this else statement and increment my counter. We'll do this process all the way until we find the number 67, which should be at index 66. But before I run my program, we forgot something, which is the break keyword. That means we want to break out of the loop when we find the number. So if I run my program, I got found at index 66. So we actually found 67 in my list. But let's say I said 670. We definitely don't have that. Well, what we'll get is not found, because we've looped inside of the list and we didn't find it, so the while loop terminates and this else statement will be printed. So that is a linear search using a while loop. Let's do it with a for loop. It is much easier. So I'll say def search. This time I'll write for. It will take two parameters, the lst and the number that I want to search. Let me declare the function first, so search for, mention the list. It will be a list of numbers or a range of numbers from 1 to 100. Then I will mention 67. Right now, let's write the code. First, I'll be needing a variable which is called position, and I'll be using this to know the position of my number. So I'll say for I in lst, if I equal n, I'll simply print the same thing, so I'll copy paste it down there. So I'll just copy paste it, but I'll change the counter to the word position. And let me tell you why later. Then if I is different than n, what I'll do is I'll say else, I'll increment the position. So position plus equal to 1. So this position will return the index value of the number if found, of course. Then if not found, I'll use an else statement that belongs to the for loop. So if the for loop terminates, this else statement or the block of code inside the else statement will be printed. So I'll say print not found. And let's see, let me just comment this one. Okay, and then let's see. So we got found at index 66, but we got also not found. That's because we forgot to say break. So I'll say break over here. We'll break out of the loop. So we got found at index 66. Let's try with, let's say, 17. So we should get 16. Found at index 16. But the problem here is that Python is searching line by line or element by element to find 67. And that is a tough process because we have a large list and we are searching for an element that is at index 66. So linear search is used on small sequences that contains little elements, not large ones. Now there is nothing wrong with searching linearly, but you are wasting time. So when the length of the sequence is growing, it will be hard for the linear search to search. But we have the concept of binary search. Now I'll create a list that is not large just for the sake of this example. So I'll say in parameters lst and of course the number that we want to search. Then I'll declare the function, so binary search. Inside of the list I'll put 7, 5, 3, 8, 9 and 2. And the number that we're searching is 8. But always, using a binary search, the list should be sorted. We could use the inbuilt function that is sorted to sort out our list. So I'll say sorted, and let me just add the parentheses at the end. And we sorted our list. Now, of course, in linear search, it's not obligatory to have a sorted list, but with binary search, you have to have a sorted list. So we have this list that is, of course, sorted 2, 3, 5, 7, 8, and 9. So, what do we do first with the binary search? First of all, we need to mention the lower value. The lower value is here, right, at index 0, and I'll call it G. Then we need to mention the upper value, which is, let's say, D, and it takes the value of the last index. In my case, it is 5. So what do we do now? First, we need to find the mid value. How to do that? We first calculate G plus D, 5 plus 0 is 5, then we divide it by 2. It will get us 2.5. But in Python, we have this concept of double front slashes, which will give us the quotient of that division. So instead, we'll get 2. So we got 2. So the mid value is actually 2. So I'll write here mid, well, I'll write m equal to 2. That means index 2. So 0, 1, 2 right here. So I'll put a bar right here. So we got the value 5 because it is at index 2. But is 5 equal to 8? No. Right now, what to do? Well, we need to change either G or D. But which one? Now, let me tell you. If the value I am searching is bigger than the mid value, what will happen is that my lower value, which is G, will take the value of my mid value, which is M. But if the value I am searching is smaller than the mid value, I should change my upper value, which is D, so it will take the value of M, which is the mid value. In my case, 5 is less than 8, so the value that I am searching is greater than M. What I need to do is, I need to move my lower value. So G will become equal to 2. So, I'll write here 2. I'll forget this one, let me just delete it. I'll delete it. Right now, we need to find another mid value. So we calculate 5 plus 2 is 7. 7 divided by 2 is 3.5. We'll get the quotient, which is 3. 7 is at index number 3. That means my mid value will be equal to 3. Right now, is 7 equal to 8? No. That means we still didn't find the value. But my lower value, which is G, will be equal to 3. So I'll erase it. I'll erase 2. And I'll shift G to 3. And then I'll be finding another mid value. So, but this time the bar moves towards here. Right now, 5 plus 3 is 8. 8 divided by 2 is 4. M will become 4. So M is 4. What do we have at index number 4? It's 8. Is 8 equal to 8? Well, yep. And we found our value. Now, how do we write this in Python? So first, we need our lower value, which is G, and it will be equal to 0. Then we need our upper value, which is D, and it will be equal to len lst minus 1. So we'll get the last index. Then I will say while G less than D, because we don't want to go out of range. What do you think we should do right now? Definitely we need to find the mid value. So mid equal to G plus D, of course divided by 2, but double front slashes to find the quotient. Right now we need to mention the condition. So let's say if lst index mid equal to n, that means we found the number. So I'll print found at index, and we'll mention mid. But let's say we didn't found it. We have two conditions left. I'll say elif Oh, we forgot to say break because I want to break out of the loop. So break and okay. Alif, lst index mid, less than. What do you think? Of course, less than n. So, what do you think will happen? Which one should I shift? The lower or the upper value? Definitely the lower value. So, g will become mid or equal to the value of mid. Then I'll say alif lst index mid greater than n. Of course, I need to shift the upper value. So d will become or equal to the value of mid. So this is the program. Do you think it will work? Well, I don't know. Let's try. So this one is for the 4. So let me just comment it out. So comment and let me rerun my program. We got found at index 4. So we actually found our number 3 at index 4. Okay. Let me say 2. We should get found at index 0. And we got found at index 0. So this is the binary search. Of course, Python didn't search in all elements inside of the binary search. But in the linear search, it searched each and every element. So make sure to comment down below which method did you like or prefer. Alright, that is it on linear search and binary search in Python. Thanks for watching today's video. This is Accent and I'll see you in the next one.